phenol. And then after that, you see, we'll discuss the, you can see the chemical properties of alcohol and phenol. So write down chemical properties of, first we will discuss alcohols. And as we know that alcohols are of three types. Monohydric alcohols are, that is the part of your syllabus, primary alcohol, secondary alcohol and tertiary alcohol, 1 degree, 2 degree, 2 degree and 3 degree. Give a chemical test to distinguish between primary, secondary and tertiary alcohol. Very well known reagent is known as Lucas reagent. It is the mixture of concentrated HCl and anhydrous zinc chloride. This is the RCH2OH. It is primary alcohol. Whenever it is made to react with HCl with zinc chloride, this is the RCH2X, 1 degree halite. RRCH and OH. But this reaction takes place only after heating, otherwise there is no possibility of the reaction. Whenever Lucas reagent is made to react with primary alcohol and then at room temperature, no reaction. But whenever after heating, it forms turbidity of the primary alkyl halite. Second is the B part, is the 2 degree alcohol, HCl with anhydrous zinc chloride. Condition is 5 to 10 minutes. This OH and H, water is lost, and then RR, CH and Cl. Once again, turbidity is obtained by the 2 degree alcohol, but the time is very important. I have mentioned in between 5 to 10 minutes, minimum 5 and maximum 10 without heating. And then finally, 3 degree alcohol is going to form 3 degree halite in presence of Lucas reagent, but at once or immediately reaction takes place, then it is the water is lost, I mean 3 degree halite, and this is what it is the. So dear students, the age of dehydration of alcohol is more the alkyl groups present on the carbon, greater the age of the dehydration because greater the positive inductive effect, and then easier the elimination of the water molecules. So here you can write here the age of dehydration of alcohol is, important to note, age of dehydration of alcohols is 3 degree, then 2 degree, and then what degree? 1 degree. Then next method is the action of copper at 300 degrees Celsius or 573 Kelvin. So again this method will be very useful, helps in separating primary, secondary as well as tertiary alcohol. Action of copper at 300 degrees Celsius. You take primary alcohol, or you can say one example here, this is the ethyl alcohol. You take better. This is the CH3 CH2OH. It is the ethanol, right? It is the 1 degree alcohol, copper at 300 degrees Celsius, H2 CH3 CHO, ethanol, or you can say acetal dehyde. Now you take 2 degree alcohol, CH3 CH3 CH and OH. It is secondary alcohol. Action of copper at the same condition, again it undergo dehydrogenation, H is lost here. So what the product formed here? Anybody? That the product formed is, okay, acetone or dimethyl ketone. So you keep in mind that in case of primary alcohol as well as secondary alcohol, they undergo dehydrogenation, As such, aldehydes and ketones are formed respectively. Similarly, in case of the 3-degree alcohol, what the product formed, anyone? Yes, let you imagine. I write here CS3 and OH. It is tertiary butyl alcohol. Tertiary butyl alcohol. Whenever same condition, so this is the, with respect to this OH, this is the alpha and this is the beta. This side is beta and this side is beta. This OH and H from any beta, what is lost? CH2 double bond CS3 and CS3. This is the 1, this is the 2 and this is the 3. 2-methyl prop 1 ene. So 2-methyl prop 1 ene. So this is the 1-degree alcohol, 2-degree alcohol and 3-degree alcohol undergo action of copper, but this is dehydration. 1-degree and 2-degree alcohol undergo dehydrogenation, loss of H2 gas, and 3rd-degree alcohol undergo dehydration. Right. So if there is the dehydrohalogenation, that means water as well as halogens are lost. In case of decarboxylation, carbon dioxides are lost. In case of dehydrogenation, hydrogen is lost. In case of halogen lost, dehalogenation. So these phenomena you will remember it. Next method is the, next chemical property is the oxidation of alcohol. So it is also very important, CS3, CS2OH. It is 1-degree alcohol. So you take the PCC. PCC is the pyridinium chlorochromate, and then water is lost, CS3, CHO, it is the ethanol. So whenever you want to convert alcohol into aldehyde, you remember a mild or the soft oxidizing agent like PCC, pyridinium chlorochromate. So it forms aldehyde, which is easily oxidized to form carboxylic acid, that is acetic acid. There is no loss of carbon. PCC is pyridinium chloro and chromate. Formula is C5H5NH CrO3 and Cl. Then it is what degree alcohol? 2-degree alcohol. This is the OH. Then it is the KMnO4 or K2Cr2O7, because you need very strong oxidizing agent. And then see, oxygen is here, HH, and water is lost, it forms acetone. So write down here, it is called as acetone. Ketone is drastically oxidized, not very easily oxidized. Therefore, it will get 4 times oxygen here, and then CO2 minus water, CS3, COOH. What is formed here? Acetic acid. 1, 2, 3 carbon, 1, 2 and 3 hydrogen, 3, 3, 6. 3 plus 1, 4 plus 2, 6 is alright. Then you come for 3-degree alcohol, CS3 and OH. It is the 3-degree alcohol undergo K2 Cr2O7 in acidic medium. Then you take 4 times oxygen, CO2 minus 2 times water, that forms acetone, and acetone further oxidized in the above manner in a phosphate form. Again carbon dioxide and water is lost, CS3 COOH. What is this? Acetic acid. So this is the method you can have, the distinction between primary, secondary and tertiary alcohol. Is it clear to everyone? So get down, note everything, and also write the name of the reactants and the products. Then next method that will help us to explain the distinction between 1-degree, 2-degree and 3-degree alcohol by taking acidic dehydration of alcohol. So next method is the acidic dehydration of alcohols. You take the primary alcohol CH3CH2OH, concentrated sulfuric acid at 443 Kelvin. Then it undergoes alpha beta elimination. See, this is OH plus H. Water is lost and then ethene is formed. Right. Of course, there is very much mechanism. We have to explain how to convert ethene into ethanol and ethanol into ethene. So during the method of preparation of the alcohol, I have explained how do you convert ethene to ethanol. 3 steps. But here, vice versa, ethanol to ethene as a part of chemical properties. Right. Okay. So here it is. But once you take 413 Kelvin, ethers are formed. So temperature plays a significant role to form the products. Whatever it is 443 Kelvin, alkenes are obtained. But once I have written 413, ethanol undergo dehydration to form diethyl ether. So temperature plays a very significant role here. So second part is it is no doubt 1 degree. So in case of 2 degree alcohol, this is what? It is the 85% H3PO4, that is 440 Kelvin. Then this is the alpha carbon and this is the beta, OH plus H. What is that? CH2 double bond CH and CH3. This is the 1, this is the 2 and this is the 3. What is that? Prop 1ene. Now in case of 3 degree alcohol, CH3 and OH, 15 to 20% phosphoric acid, and temperature is, I think, most probably 358 Kelvin. Right. So this is the alpha and this is the beta or beta. Beta 3 beta are at the equidistant point. So you can take H from any beta, water is lost. So dear student, here OH plus H. What is lost here? Water is lost. If I take H from this point, IPAC name will remain same. CH2 double bond CH3 and CH3. This is the 1, 2 and 3. 2-methyl prop 1ene. So write down properly everyone and make a note. 2-methyl prop 1ene. So this is the another method to distinguish between primary, secondary as well as tertiary alcohols. Now write a question and complete it. That is most probably the board paper. Usually write the reaction mechanism of ethanol to, what is that? Ethene. So answer, mechanism is believed to be in 3 steps. Ethanol, whenever in presence of the concentrated sulfuric acid, then the alpha beta elimination, water is lost, alkane is formed. I mean ethene, because you took ethanol, ethene is formed. So the mechanism is believed to be in the 3 steps. First step is formation of protonated alcohols. So here formation of protonated alcohol. So see, if I write ethanol, you know it very well, ethanol is bit basic in nature also because of the presence of the lone pair of the electron, and here it acts as a nucleophile. So it reacts in presence of the sulfuric acid, to sulfuric acid release hydrogen. So in mechanism we have to prove the catalyst never consumed, it will be regenerated. Finally we will prove it. Whatever we take first, hydrogen ion from the sulfuric acid, then this will provide the lone pair to the H, CH3 CS2 OH, ethyl oxonium ion, ethyl oxonium ion. Then second is formation of, what is this? Carbocation. Take ethyl oxonium ion here, CS3 CS2 OH, positive charge in lone pair, and this carbon going to support the oxygen to remove the positive charge. Water is lost, plus CS3 CS2 positive, ethyl carbocation. Third is the deprotonation. So see here, CH3 CH2 positive charge, and this H will give the here, and it will out now. H plus is out in the form of, or you can say H3O positive, H positive plus water that combine to form hydronium ion, and then ethene is obtained. Right. So we have proved that ethanol to ethene. First of all, you take ethanols to ethane, formation of protonated alcohol. So once we provide the proton, alcohol is a base, nucleophile, they will react to form conjugate form, ethyl oxonium ion. Then we take formation of carbocation, and the mechanism is finally deprotonation or elimination of the proton or loss of the proton. So dear students, in that way we have obtained the mechanism of ethanol to what? Ethane. But you remember, during the preparation I have explained ethene to ethanol. Another important chemical properties of alcohol is formation of halite. So if I take, now next is the formation of halite, right? CS3 CS2OH plus PCl5 minus POCl3 minus HCl, CS3 CS2Cl, ethyl chloride. I take CS3, now CH2OH plus SOCl2. This is what actually SOCl2 we have done in the alkyl halide thionyl chloride minus SO2 minus HCl. It is better method than PCl5 because impurities are removed in the gaseous state. So if you have to choose the option, either you want to take PCl5 or thionyl chloride, so better from me side is that you have to prefer thionyl chloride. It's clear. Now further the formation of halide is CS3 CS2OH plus PBr3. So you take, you see 3 molecules here. Now H3 PO3 lost, and then CS3 CS2 and Br. So in that way you prepare that the chloride, bromide and whatever it is. Normally CS3 CS2OH plus HCl and zinc chloride, OH and H is lost here, right? Heating, then it forms CS3 CS2 and Cl, ethyl chloride. So alright, now see, chemical properties of alcohols are finished. Now dear students, next is I would like to explain you can see one reaction you can add also, reaction with metal like sodium, aluminum. So whatever it is, the CS3 CS2OH plus sodium metal, right? So then it forms CS3 CH2ONA plus half time hydrogen gas. It is the sodium ethoxide and hydrogen gas is liberated. Now this alkoxide will be helpful in preparing ether during the Williamson esterification reaction. Okay, right? Next is the, you can say you take 3-degree alcohol CS3 3 times alkyl alcohol. Right now this is the 6 time plus 2Al. It forms CS3 CO. It is the aluminum. This is the 2 times or 3 times plus 3 times hydrogen gas. Aluminum. Anybody tell me the name of this product here? What is this? Aluminum tertiary butoxide. Aluminum tertiary butoxide, right? So here you can add here aluminum tertiary butoxide.